So I'm going to be giving you a brief demonstration of how to identify some commonplace behaviors and practices associated with malware. Before we dive into today's topic, I want to make it absolutely clear that malware analysis can be a complex and potentially hazardous activity, and I strongly discourage anyone from attempting to analyze malware in their own environments or on personal devices. Doing so can lead to unintended consequences, including data loss, system compromise, legal issues, actual malware infections, and so on. Neither the authors of this video nor any involved party can be held responsible for any consequences that arise from attempting to replicate any analysis shown herein. This video is intended for educational purposes only. So, with that out of the way, today I have a single file on the desktop, as you can see on the screen. As part of this activity, we're going to perform a basic initial triage of the file to determine if we believe it is malicious, using some tools and techniques that are commonplace within the field of malware analysis. So what we're going to do first is open a tool called PE Studio Malware Initial Assessment. I've done that earlier, so I'll just bring it up on screen for you to see. What PE Studio does, in a nutshell, is compile a series of indicators of compromise, key metadata about a file, and various interesting pieces of information to a malware analyst, and compiles it really into one place for us to take a look at. We can use this information to really drill down into what we think an application is doing, why we think it's doing it, and actually how it's doing that. So we'll come on to imports and exports later on in terms of what this program is doing. But first of all, we'll jump to the resources section for reasons that will become clear in a minute. So, as you can see here, if I open the resources section, so now that I've opened the resources section, you can see a series of entries relating to individual pieces of data within the executable file itself. Those resources are additional parts of the application, so for example, the icon that you can see on the actual screen, potentially, some key information about versioning, some key information about how the application should be executed, the user that it should execute as, and other key bits of interesting information here. One thing that Malware Initial Assessment has picked out is the file ratio. So what this is basically showing is how big each of these entries are within the application itself. And you can see this XIA 2058 entry takes up pretty much all of the available storage space. If we take a look at the signature column is denoting what it believes the actual entry is in terms of, does it believe it's a image, does it believe it's another program, or something else. We can see here several of these are actually identified as icons, versions, manifest information, similar. But this XIA 2058 has actually got a signature of pkzip. Pkzip is commonly used to refer to a zip file, which is generally used as an archive format to store further files, which in itself isn't strange within an application, but what makes it strange is the very large size, which indicates that this application might not actually be doing that much. It might be the case that it's loading this very large zip file from within itself. If we scroll along further, we can see entropy values. What entropy values are essentially a measure of randomness within the application itself. I won't get into entropy in a long conversation because we'll be here a lot longer than the 5 minutes of this video, but in a nutshell, for what we're looking at here, basically a low entropy value indicates very structured data, a high entropy value indicates very random, very garbled data. So entropy within malware analysis is commonly used to identify potential encryption, obfuscation, or packing. And as we can see here, the maximum value of 8 is assigned to that pkzip file. So what we can then infer from this is this application has a very large embedded potential zip file within it. That zip file, not only is it very large, it also appears to be encrypted because it has a very, very high entropy value. What we've got here are the first bytes of the individual components within the resources section, and we can see here some magic numbers associated with PNG files, portable network graphics, and we can see here the magic number indicated for a pkzip, a zip file, that 504B0304, so on, so on, so on. So now that we've had a look at the resources, let's take a look at the imports. Imports relate to the individual functions and methods that this particular application is pulling in from Windows and is using to do various things within the application. What Malware Initial Assessment here has done helpfully for us is it's shown all of the imports, and it has then flagged what it believes are high-risk imports that are commonly used for suspicious activities. Just because something's flagged doesn't necessarily mean it's suspicious, but there are perfectly valid reasons to create a service, to create and modify registry keys. But if you've got a suspicious file that you're not entirely sure of, and you can see things like it's creating services, it's creating registry keys, those are probably elements that you're going to want to take a look at in a little bit more detail. So let's quickly run through some of the flagged items. So we can see this application seems to create service, create and write registry keys, allocate memory, seems to apply some form of protection to that memory, write files, seems to set file attributes, so indicating what users can read and write whatever files it drops, presumably. Could then see further on, it creates a process, terminates processes, maybe perform some kind of error checking on the status code when a process exits. Interestingly, we can see a couple here, a couple of cryptographic functions, which are a little bit strange for an innocent application to use. And then if we scroll down further, I won't go through all of these because we're going to be here a while. Now, as you can see, it seems to be doing quite a few different things. But generally, from what we know so far, we've got an application with a very large, presumably encrypted zip file within it, and that application seems to create services, create registry keys, allocate memory, protect that memory. It seems to do something cryptographic and around random number generation, presumably, or potentially even key generation with something, creates processes, writes files, checks status codes, and creates processes. And what we can piece together from this is potentially this program actually writes the embedded zip file, that XIA2058, potentially writes that to disk and then potentially launches it. So what we can do next is load it into a program called Resource Hacker. What Resource Hacker will allow us to do is take a look at some of those resources within the executable itself, which is what we're going to do now. So there you can see this XIA2058, which we saw from Malware Initial Assessment over here. We can actually take a look at it and get a hex dump of it. If we look at that in detail, we can see again some of those magic numbers at the start associated with the zip file. We can then see a couple of interesting strings that stand out to me. We can then see WNRY, OneRy. If we scroll down further, really what we're doing here, we're just doing a brief skim. We're not looking for anything in particular, we're just looking for anything that immediately stands out. This is a lot of information to read through if we were to scroll through the whole thing, so we're not going to do that. We're just going to quickly scroll to the end, which is usually where some of the more interesting information will lie. Okay, we can see what looks like some kind of file structure or some kind of abstraction of files or pathing. We can save this bin resource, this XIA2058, and we'll save it to disk. In this case, we'll rename it as zip because that's what we think it is, and we will save that to our desktop. If we take a look at it, we can actually see our suspicions were right. It was a zip file, and we can actually see that the contents are password protected. So in this case, we cannot access whatever these files are without a password. presumably this application contains that password and likely decodes it on the fly as required. In another video, we might look into actually extracting the password using a bit of reverse engineering to take a look at some function graphs and various different bits and pieces that are running and extracting strings. But for the purposes of today, we're not going to be looking at that. It's safe enough to take a look and essentially have this confirm our suspicions that this application appears to be dropping a zip file to disk. That zip file seems to contain a bunch of encrypted files that it presumably decodes on the fly. So to end the analysis, I'm going to do a bit of dynamic analysis where I'm actually going to launch the application itself. So I'll just give that a double click and we will see what happens. As you can see there, pretty much immediately off the bat of launching that, a series of files are dumped to the disk. My background is changed. I have a pop-up from UAC. If I expand the details on that, we can see what this is trying to do. We can see here this command is actually trying to delete any shadow copies associated with the disk. We can then see it's actually executed with the silent flags to try and avoid detection. Repeated use of quiet throughout, where it's trying to do this silently in the background. And as you can see, what this has actually done is launched WannaCry. WannaCry was a very virulent strain of ransomware crossed with a worm, often referred to as a crypto worm, that impacted the world in 2017, most notably the National Health Service of the United Kingdom. As part of that, WannaCry used an exploit to essentially worm between various SMB shares and use that to replicate itself. And what it would do is it would replicate, then it would look for particular files, PDFs, PNGs, documents, docx's, Excel, SX's, basically any documents that could be of use to anyone or might have been, containing useful information. And it would run through that list and it would then encrypt those files using asymmetric encryption and offload the actual decryption key to the attackers, who would then only hand you the key in exchange for Bitcoin sent to the address that you can see on screen there. To really sort of add to the pressure and the social engineering aspects of that, as you can see on screen, you've got several countdowns. If you don't pay the attackers by the date shown on screen, you would, well, first of all, I think you get a couple of days grace, and then after that, the payment required doubles. And then after the time shown in the your files will be lost on dialog box, after that time, they state that they will erase the asymmetric decryption key, which means that your files will be permanently encrypted. So I hope you found that a useful and interesting insight into some basic malware analysis of WannaCry, looking for a couple of key indicators of compromise and suspicious activity. Thank you.